Welcome back to the office. Let's take a look at an example of multiplying permutations. Right? We said that the symbol that we use to represent combining of permutations, these functions, is multiplication. Right? There's the implicit multiplication of no symbol written. But what we're really doing here is we're performing function composition. And yet it's so weird because this is such a different representation for a function than we've ever seen before. So this is very strange. First, let's take a look at the functions sigma and tau, which are permutations of the set 1, 2, 3, 4. All right. Sigma of 2, for example, is equal to 1. Oh, well, it happens to be that tau of 2 is also 1. That's interesting. Let's see here. Sigma of 1 is equal to 4. Cool, right? Sigma of 2 is 1. Okay. Sigma of 1 is 4. That's what we get. Tau of 3 is 4. And tau of 1 is 3. Cool. Hey, so just trying to remind us what it looks like to evaluate these functions. All right. Now, if I wanted to combine our two functions together, let's evaluate sigma tau. What we want to remember is that we are evaluating this, or we are combining them in a in a right to left sense, from right to left, from right to left. So I'm going to write down our two permutations, 1, 2, 3, 4, and sigma is first, 4, 1, 2, 3, and we are multiplying that with tau, 1, 2, 3, 4, 3, 1, 4, 2. Excellent. If I want to combine these, what I would do is I just look at what happens to each element. So I'm looking at these element-wise, is what you can call it. So 1, 2, 3, 4. So when I evaluate sigma tau of 1, sigma tau of 1, I recognize that this is sigma of tau of 1. Oh, there we go. Now, tau of 1 is 3. Tau of 1 is 3. Sigma of 3 is 2. There we go. So I can just write 2 right there. No big deal. Now, I don't have to write this out every single time. What I can do is I can just follow along with what happens. So what happens to 2? Well, 2 is sent to 1, and 1 is sent to 4. Again, remember that this is function composition, so we're working from right to left. All right, what happens to 3? 3 gets sent to 4, and 4 gets sent to 3. So 3 stays at 3. And what happens to 4? 4 gets sent to 2, and 2 gets sent to 1. So our new permutation is this thing, 2, 4, 3, 1. Excellent. Now what about tau sigma? I want to perform this composition in both ways, so that way I can observe that function composition, or recall that function composition is not necessarily commutative. I'm hoping that I didn't choose a poor example here. All right, so tau of sigma, tau is this, so 1, 2, 3, 4, 3, 1, 4, 2. And sigma is this, 1, 2, 3, 4, 4, 1, 2, 3. Excellent. Now what I would like is I would like to evaluate this, come up with our new permutation. So 1, 2, 3, 4. Where is 1 being sent? 1 is being sent to 4. 4 is being sent to 2. Excuse me. Again, 1 is being sent to 4. 4 is being sent to 2. Oh, what's happening to 2? 2 is being sent to 1, and 1 is being sent to 3. What's happening to 3? 3 is being sent to 2, 2 is being sent to 1. And what's happening to 4? 4 is being sent to 3, 3 is being sent to 4. Excellent. So this is our new permutation. And of course, we can see that despite the first entry being the same, the remaining are not. 2, 4, 3, 1 versus 2, 3, 1, 4. So in particular, we want to recognize, as is expected, that sigma tau is not equal to tau sigma. Function composition is not commutative. All right, not a big deal. That's it for this example. Pretty straightforward. We wanted to find the products. Okay, product notation. Composition is the actual binary operation here. And what does it look like for us to find that composition? Well, that's what it looks like. Excellent. If you have any questions, be sure to ask. Otherwise, I'll see you guys back in the office for a little bit more on permutations.